All right, so hi guys. I wanted to give you guys a couple of examples with how to solve inverse or solve for an inverse, make an inverse of a function. So then that way we don't, you've got something to refer back to. I'm going to go through three different ones. Remember, three steps. First of all, you need to swap x and y. You then need to solve for y. And then the last step is write in inverse notation, write as inverse. So that's, f inverse of x. So first of all, again, remember we're going to treat the function part as y. So we're going to swap those. And then welcome back to the beginning of the year. This is actually welcome back to Algebra 1. So then y is going to equal 1/4 x minus 5/4. This again, you can divide everything through by 4. So the inverse of x is 1/4 x minus 5/4. Stick it in a box. The linear ones are pretty easy, and you'll have a couple of those. That is going to be like a basic level problem. Again, that's part of the reason why I said you would have seen it in Algebra 1. That's what you would have been expected to leave the class with. So let's ramp it up a notch. Not too much. G of x, x squared minus 6. I'm going to give ourselves a little bit more room here. Make this a little smaller. So again, the function is really y. We write it in function notation because that's your output. We're going to swap x and y. There's step 1. Solve for y. So then y is going to equal plus or minus square root of x plus 6. Now, two things you're going to see in the book. They're going to ask about one-to-one functions. That you don't need to worry about right now. That's pushing a little bit more of the college course that the book was intended to teach. They're going to see some stuff with domain and range. The domains are called because, if you notice, this right here is not a function. And it's not a function because you got plus or minus. If I plug in one x value, I'm getting two y values out. So oftentimes what they will do is in a problem like this, they will say something like where x is bigger than or equal to 0. They're going to do an input or limit your domain like that. Obviously, if we were writing it, we'd write it like this. And so because of that, when you do that, then that would also then limit your function to this. And we'll talk more about that as we go. I'm more interested in the process right now than worrying about the domain and range. But so we'll write this as the inverse of g of x is equal to that. But I'm just pointing that out so then that way you don't have to worry about, somebody saying it later and then you saying, well, Mr. Hayes lied to me because, again, I'm more interested in this process here than the domain and range part right now. We'll take care of that more later this week. Last example is a rational, like what we've been doing more recently. Again, you're going to do the same thing. H of x, we're going to replace with a y. So this is going to equal x is going to equal y minus 3 over y plus 7. Rule number 1, multiply everything out. And you're going to get everything with a y in both sides. So I'm going to multiply both sides through by y plus 7. So now I have x times y plus 7 is equal to y minus 3. Now I have to distribute this out because, again, we need everything in terms of y on one side. And this is usually some place where somebody freaks out. Remember to breathe. Take your time. You don't need to, send anybody to the hospital yet. So I've got x minus y, and I'm going to put all the y's on one side and move the x's on the other. Because, again, I'm going to rewrite that up here. Now, this is not, you don't do anything fancy with it. Don't say, oh, well, it's like, x minus 1. Just chill. Hold on. So how do I get it so I don't have two y's? How can I get it so I can combine those? Easiest way to do, factor it out. And then you can go ahead and divide through by that factor. Now, if you can factor things out, that's great. Don't divide the x's out. I know some of you are tempted to. Remember, that's just bad. People will be made fun of if that happens. Okay? So this just turns out to be your final answer. So we're going to write it in inverse notation. So we get that. In fact, let's even just clone it and we'll move it up by the original. Now notice it does have some similarities to what's going on up here. Okay. But again, those are going to be two things I didn't. So if you graphed both of them, you would see them as inverses, and that's a good way again to double check them. You just take them in the graphing calculator, plug one in for y1, one in for y2, probably also graph x equals, and go from there. Let's see. Yeah, well, why not? I'll go ahead and just actually do that for you. There's one small thing. Oops, this classroom doesn't have it set up for me. So much for that one. Anyway, we'll take a look at that in the first thing in class tomorrow. And with that, work hard, be good for your subs. You're in good hands. And I think that's about it. We'll talk to you later.